Oh, hello my dear friends. Welcome to a new video. Today we're going to solve the reverse linked list on LeetCode. As an input, we will have a linked list. And as an output, we need to return the reversed version of that linked list. Like here in this example, we have 1, 2, 3, 4, 5 in our linked list, and we need to return 5, 4, 3, 2, 1. At the beginning we had 1 as a head and 5 as a tail, but in the second linked list we have 5 as a head and 1 as a tail. For the second example, 1, 2, we had now 2, 1. And for the last example, if we have an empty linked list, that means a null linked list, we just return a null value. Perfect. Now let's see how are we going to approach this problem. We have actually two approaches, an iterative one and a recursive one. Let's see the first approach, the iterative one. Well, in order to solve it, we will need a couple of placeholders, a couple of variables. The first one, I'm going to call it current. The second one, I'm going to call it previous. Okay. My current will be initialized to 1. So my current will hold the reference to the first node, that is the head. And my previous will be initialized to null. Cool. And then I'm going to have a loop. Obviously, I need to loop through all these elements. But before that, I will need a third placeholder, a magic box that I'm going to call next. This next will hold the value of the next of each node, so that if we remove, if we change the next of this actual node, we won't lose it. Okay, it's gonna become clearer in a bit. Just bear with me. Okay, so now my current is pointing to 1 and my previous is pointing to null. Now the first thing I'm going to do is put the 2 in here in the next, because I'm going to update the next of 1. So before that I need to keep track of the previous next before updating the 1. Okay, I need to keep it somewhere. That's what I'm going to put it here. Okay, cool. Then I'm going to remove this link, and 1 now will point to the previous. So 1 is going to point now, its next is going to point to null. Perfect. And now the previous is going to be the current, that is 1. Okay, and the current is going to be the next. Okay, so we've made some swaps to go through to the next iteration. Now my current is 2. Okay, so before doing my change to the next of 2, I need to keep this value somewhere so I can reuse it later on. That's why I need to put 3 here. So my next holds a reference to 3. Now my 2 needs to point to the previous, and my previous is 1. So the link between 2 and 1 will be created, but in this direction. 2 now is pointing to 1. And now I finished the linking, so I can update my current and my previous. My previous will now hold 2, that is the current value, so the current will become a previous value. And the next value will become a current value. It's so simple and easy to understand. Just gonna fix this, write it better. Cool. Okay, now we have our current, and obviously I have destroyed this. Sorry, I forgot to remove this, to clean this. Okay, this link don't exist anymore. Okay, now 3. Before doing any updates to 3, I need to keep track of its next, that is 4. Okay, now 3 is going to point to the previous, that means that is 2. And this link won't exist anymore. And now I'm going to update my previous and the current. My previous will hold the current, that is 3, and the current will hold the next element, that is 4. And again, before updating 4, I need to make some changes. Before making some changes, I need to hold the reference of 5, that is the next of 4. So I'm going to put here 5. Okay, and then what I'm going to do next is my 4 now is going to point to the previous, that is 3. This link won't exist anymore. Okay, perfect. Now I can update my current and previous. My previous will point to the current element, that is 4. So now I can put 4 here, and my current will take the next element, that is 5. Cool. Now the next, what value will next hold? Well, here there is null. Okay, so now my next will hold null. Okay, and my 5 will be linked to the previous. So I'm gonna put 5 here like this, and it won't be linked to null anymore. Okay, perfect. So now my previous is okay. Now my previous will hold 5. Okay, 5. I'm going to put 5 here, and my current will hold null. So I see that my current is holding null. That means that we've reached the end of the loop. And other thing is that previous is now pointing to 5, and 5 is the new head. Is the head of the reverse linked list. So what I need to do is return this previous at the end, so that we get the head of the reverse linked list. Cool. Now let's try to code that. Okay. So as I said, we will need a couple of variables. The first one is current. That would be initialized to the head. The second one would be this node previous. That would be initialized to null. And the last one would be the next. That would be initialized to null too. And we will need a loop where we check each time that the current is different from null. Then the value on next, we're going to put the current dot next, because the current dot next is going to be updated, so we need to keep it somewhere. And now we can update our current dot next. What are we going to put here? We're going to put the previous. Cool. And now we can update our current and the previous. So the previous will hold the current. So the current value will become a previous value, and the current is going to be the next. Okay, and then we return the previous at the end. Okay, so I don't need to initialize it here because it's gonna get the value here anyways. So here, current.next, we keep it in the next, and in the current.next we put the previous. And after all, we need to update the previous and the current. So the previous, we're going to put the current value, and in the current, we're going to put the next value. And we need obviously to respect this order, or it won't work. So let's run the code. Hopefully it works. It does. Let's submit the code. It does work. Great. So let's talk time and space complexity. For the time complexity, it's going to be O of n, because we have to go through all the elements. And the space complexity is going to be only O of 1. Perfect. Now let's see the second approach. I'm going to rewrite again the linked list. Okay, so this time we're going to use the recursive approach. So imagine with me, we have the recurse function, so reverse linked list already existed. So if I want to reverse all this linked list recursively, what I need to do first? What I can do is first reverse this. if I reverse this, like I'm having now 4, 3, and 2, okay, so I recursively reverse this linked list. What I need to do then is go to the tail of that reversed linked list and then put 1. Okay, but the problem is how I'm going to reach the end of my linked list. Do I need to loop through all my linked list? That doesn't sound a really good solution. Okay, but what I can do is, at first, just gonna remove this. Actually, before going to the before reversing this linked list, I can keep track of this element. I'm gonna put it in a variable like tail, call it tail. It's going to be the head next. So the head and next. So it's going to be the value 2. And obviously 2 is going to be the tail when we reverse this linked list. Okay, so 5, 4, 3, 2. This way, after we finish our recursion and we've got our reversed linked list, we still have in our variable the 2, so we can just put 2 in the next of 2, or we've saved it in a variable, we can just put 1 here. Okay, so this is how you need to think with recursion. You suppose like you already have this function that solves the reverse linked list for a part, and you need to find a way to make it work for all the linked list. So you just remove one element. You suppose that the function works for this part, and you need to find a way to make it work with this new element. Okay, and also you need to pay attention to the last recursion, or the limit recursion, or the initial state, so that will stop the recursion, because if you don't have a stopping point, the recursion will go indefinitely. And when are we going to stop? We're going to stop our recursion if we have no longer a linked list, that means null, or if you have only one element. Because if we have only one element, we don't need to do anything. It's already a reverse linked list itself. Okay, so perfect. Now let's write that code. We're gonna remove everything here. So first of all, we need to write our stopping condition. Okay, that is head equals to null. We return null. And if head dot next is equal to null, what we need to do, not return null, there will be a mistake. We need to return the same element, the head, that element, its corresponding linked list. And we can fuse these two conditions into one like this. If head equal to null, or head dot next equals to null, return head. So if it's null, it's going to return null, and if it's not null but the next is null, it's going to return the head. So that's what we want. Okay, and as I said, we're going to keep track of the tail, this node tail, this head dot next. And as I said, the head dot next will be the tail when we use the recursion of a reverse list. So this node sub reversed list, because we're just gonna reverse a part of our linked list, and I'm gonna use the reverse list without taking into account the head, but starting from the head dot next. Okay, and now when I have my sub reversed list, what I need to do is in the tail dot next, what I need to put in the tail dot next, recall me, yes, we need to put the head. Okay, so our new the first element needs to be added to the end of the sub reversed list. And we can obviously return sub reversed list. Okay, it's a poor choice of names. I'm just gonna call it reversed list, because at the end we're gonna have a reversed list. And actually we don't even need to have this. We can put directly here head dot next dot head, because the head dot next head dot next won't be lost. Okay, it won't change while doing a reverse list, so we don't need to keep track of it before doing the modifications. Anyways, we ran the code, found cycle in the list node. Oops, my bad. And obviously now the head of our linked list will be a tail in our reverse linked list. Okay, that's right. That means that head.next must be null. It should not point to any nodes anymore. Okay, because now it's a tail, and the tail always points to null. So that's why we need to do that. I'm glad I've done this mistake so that you can learn from it. Okay, I'm going to run the code. It works. I'm going to submit the code. And it works. Let's talk time and space complexity. For the time complexity, it's still O of n. But for the space complexity, it's going to be O of n. Because now we have a call stack. And call stack is in memory. And each time we need to put a call function in our stack n times. Okay, but still, so the iterative approach is better, but still it is good to see the two approaches. So that's it. Thank you for watching. See you in the next video. Bye.